The basic cooling circuit is what I have wired on this board. Okay, so what we have a powered board. If I turn the fan switch on, okay, to fan on the thermostat, we give it a second for the thermostat to respond, okay, and the fan here will eventually come on. We're using the green light bulb all the way on the side for the fan. Okay, now if I put fan back to auto, which I'm going to do now, the fan is our indoor blower. I put the fan back to auto, we're going to, as soon as the thermostat responds, turn the fan off. Now, I'm going to put the thermostat into cooling mode. Okay, and I'm going to turn the temperature down below the room temperature. Did you see how that happened? The thermostat actually came on and turned the indoor fan, which is the green, the compressor, and the outdoor fan on. Now, we were talking about the different components. This over here is my compressor contactor. My coils are on the outside. I have line 1 and 2 coming in. I have line 1 and 2 coming out to the load. My indoor fan relay is over here. Again, G terminal from the thermostat, okay, and a Y terminal from the thermostat is this yellow wire to the contactor, and then we have common on both, the indoor fan and the compressor contactor to go back to the common on the transformer. A few little voltage readings here we can do. Okay, if I hang my meter up here, okay, I could take a voltage reading across the yellow and common. Okay, and I'll get 26.91 volts because that's telling us that that contactor is energized. If I do the same thing on the coil down here, I'll get 26.91 volts. It's telling me that the coil's energized. Let's see if I can get that meter to show there. Okay, I can get my 26.91 volts there. Okay, or 26.9. What if I go from L1 to L2 down on the bottom? Okay, I'm going to get 124 volts. Okay, that's what the line current is here. On a system out in the field, you'd get 240 most likely. Up here, because our contactor's closed, we're getting the same, well, I'm getting a little bit of a voltage drop. I'm going to 120, there we go, 124, 123.9. Now, because the switch is closed, voltage across a closed switch is 0. So if I go L1 to T1, which is my load side, okay, I get 0 volts. That's because the switch is closed. What happens if I go and turn this now back? I'm going to turn the temperature up above what my space temperature is. We're going to turn everything off. What do you think is going to happen to the voltage across the contactor? Okay, let's let this turn off. There we go, we have everything off, thermostat satisfied. So my voltage across my contactor is now okay. It's now 124 volts. Okay, voltage across a closed switch. Okay, what about across my thermostat connections? Okay, am I going to get any power? Am I going to get any sign of voltage here? No, because the coil is no longer energized, 0 volts. Remember, I got 26.9 there a little bit ago. Now, it's a little bit out of your picture, but we have our transformer over here. Okay, if I come down to where my transformer is, won't hang that there too long because I don't want to break anything. But primary side of my transformer, that's a load. Okay, I have 124.1 volts. Again, tough to see on the meter. What about my secondary? Okay, my secondary coil is getting 28.6 volts right at the coil. What if I measure across primary and secondary together? Am I going to get anything? 48. So that number doesn't make sense. So if you ever get a number that's outside of the realm of what the transformer should do, it's because you're going across primary and secondary. Secondary should always be in the 20s, above 24. Primary should be whatever your incoming line voltage is. Okay, now on the thermostat side, if I remove, let me put my meter back to where we had it. Okay, so I can pull the thermostat cover. I'm going to pull the thermostat off, and we're going to look at the subbase. So if I open my thermostat up, now I have access to the wires on the subbase. Across R, I'm going to have to take my R from there, and C, I should have my 28 volts because that's my transformer. Across R and W, okay, I do have a voltage drop, okay, so I have 10.3 volts there. Okay, that's some line loss. What across R and Y? 28.6 volts. Okay, R and G, 28.4 volts. Remember, voltage across an open switch is always source voltage. Okay, so a closed switch is my thermostat calling. Okay, and that would be, so if I go put my thermostat back on here, okay, and if I find G to R, I'm going to go again here, and I'm going to use my G terminal over here because that's basically where that wire goes. G to R, I have 28.53, open switch. Think about the schematics. If I go back over here and if I turn my fan to on, okay, I don't know if you can see that meter really well. It's tough to see. Okay, but now I have power there. G to R now is 0 because it's a closed switch. Voltage across a closed switch is always 0. What about if I go G to common now? 27. Voltage across a powered load is source. Okay, and if I come over here to this light bulb that's over here, okay, 124. Voltage across a powered load is source. Let's turn this back off. Turn the fan auto. Now it's no longer powered. I get a little insignificant number of 6.5, but again, that's because there's a little bit of line loss in this board for some reason. So that's basically how the basic cooling circuit works. So let's review again how that works. Okay, fan switch is independent. Fan auto and fan, oops, let's put this back on, and fan on. Okay, fan auto and fan on. Okay, so fan auto, that cycles with the cooling circuit. So if I put this back into cooling mode and decrease my temperature down below space temperature, we'll let that set for a minute. We may end up with a little bit of a delay. We have a flashing cool light over there, so we're going to end up with a little bit of a delay. But we should eventually here go into cooling mode. Again, there's a time delay on most thermostats. So there we go. We now have our heat or our indoor fan motor, our condenser fan motor, and our compressor all running because we're in cooling mode. Temperature satisfies, and I'm going to cheat because this one isn't going to satisfy, and I'm going to push that up to 90 degrees, make sure the space is Temperature is under that of the thermostat, and you'll see that open, and all are going to cycle off on the time. We don't have any safety switches in this circuit. This is strictly a cooling circuit to get the indoor fan, compressor, and outdoor fan motor running.